Today we're going to be finishing up Chapter 1, working on exponents and order of operations. And we're going to start with exponents and what they mean and some of the vocabulary surrounding them. If I have 3 to the 5th power, so that's how this is read. 3 to the 5th power. 3 is what's called my base. And 5, the small letter up top, is called the exponent. The base is the number being multiplied by itself. And the exponent tells you how many times to multiply it. So, we have the base and we have the exponent. So, 3 to the 5th power equals 3 times 3 times 3 times 3 times 3. So 1, 2, 3, 4, 5. So, two different ways to do that. We could just literally do 3 times 3 times 3 times 3 times 3, which gives us 243. Or, on the calculator, we do 3, and then this key above the division key, this little arrow, up arrow, which is called a caret, 3 to the 5th power, gives us as well 343. So, that's what an exponent does. Tells us how many times to multiply the base by itself. Now, one thing that you need to be careful about, of course, as always, are negatives. So negative 3 to the 5th power and quantity negative 3 to the 5th power are two different things. We'll go to a different example shortly. So negative 3 to the 5th power means negative 3, and I'm going to use the dot because I'm already using parentheses, 3 times 3 times 3 times 3 times 3. So this would be negative 243. Quantity negative 3 to the 5th power means negative 3 times negative 3 times negative 3 times negative 3 times negative 3. As we learned in the last lesson in 1.7, 1, 2, 3, 4, 5 negatives gives me still a negative because it's an odd number, so this is 243. So in this particular case, it didn't end up making a difference, but here's where it does make a difference. If I have negative 3 to the 4th power as opposed to negative 3 to the 4th power, quantity negative 3 to the 4th power, then this is negative 3 times 3 times 3 times 3, which is, if we do it like this, negative 3 to the 4th with no parentheses gives me negative 81. On the other hand, if I do quantity negative 3, that's negative 3 times negative 3 times negative 3 times negative 3. We know that's 1, 2, 3, 4 negatives, so an even number of negatives, which means this is going to be a positive 81. So the difference on your calculator is parentheses negative 3 to the 4th power, and that's a positive 81. So that's where you need to be careful about your exponents and where you put the parentheses. I would get in the habit of always putting parentheses around a negative in the calculator, but also recognize that your calculator can make mistakes. So if you do negative 3 to the 4th power and you're meaning to take negative 3 and multiply it by itself 4 times, then you need to make sure to put parentheses around it. Be smarter than your calculator in those particular cases. Just a few more examples. 4 to the 2nd power. You might also hear that as 4 squared. 2nd power is often referred to as squared. So 4 times 4 is 16. Negative 5 to the third, negative 5 times negative 5 times negative 5. So just to do this a little bit longer way, negative 5 times negative 5 gives me a positive 25. Drop down that negative 5. 25 times 5 is 125, so this is going to be negative 125. So that's just a few more examples of those exponents. Now we'll move on to the order of operations. Just kidding. We're actually going to move on to simplifying algebraic expressions. So as we have in the past, you need to combine like terms, and we want to be really clear about what like terms are. If I have 7x to the third plus 2x to the third, those are both x to the thirds. So if I have 7 of them, adding 2 of them, then that's simply going to be 7 plus 2 is 9, x to the thirds. If I have 5x to the thirds and just a single x to the third, which is 1x to the third, that's going to be 5 plus 1, which gives me 6. I'm sorry, x to the second. I meant to say x to the second. Now on this third example, I have 3x to the second plus 4x to the third. So if I look at that as 3, let's look at the x squareds as just squares. So I've got 3 squares. And then I have 4, x to the third. Let's look at those as cubes. So if I have 3 squares and I have 4 cubes, so 3x squared plus 4x to the third, I don't have 7 squares or 7 cubes. I still just have 3 squares, so 3x to the second, and 4 cubes, so 4x to the third. So I cannot combine these two because they're not like terms. So my answer is just the original problem because it cannot be simplified any further. Okay, moving on to order of operations. The first thing you want to start with is the parentheses, and that's what we know most commonly say, but we can also look at it in a couple different ways. Perform all of the math inside of grouping symbols. So that can be parentheses, that can be brackets, that can also be absolute value symbols. So you do everything inside of the parentheses first. Then you move on to the exponents. Evaluate all exponential expressions. So you do the 2 squareds, you do the 3 to the 5th, that kind of thing. You do all those first, or second, sorry. Then you multiply and divide in order from left to right. So in English, we read from the left side to the right side. We do the same thing in math. The only exception is if your expression looks like this. So 5x squared plus 6 times 4 divided by 6 plus 2 squared. Then you're going to want to simplify the entire top part with the order of operations, simplify the bottom part with the order of operations, and then you're going to divide the top by the bottom. So you're going to basically do the order of operations on the top, order of operations on the bottom, and then your last step will be to divide the top by the bottom. And then finally, your last step is to add and subtract from left to right. Or you can also change the subtraction into adding the negative and then combine everything. So that's how it goes. Parentheses, exponents, multiply and divide, add and subtract. I should note later on when we're solving, we're basically going to work that backwards. So make sure you don't confuse. Right now we don't have any equal signs, so we're not going to be solving just yet.